Hi everyone, welcome to my channel Fundamentals. Today we are going to see 12th standard physics chapter 2 current density and under that a small topic known as drift velocity. So what is velocity? Velocity is nothing but we say it is the speed at which a particular object moves. For example, take a train. Say there is a train. It is moving about 50 kilometers in maybe 1 hour. Then we can say that the speed of the train is 50 kilometers per hour, which is nothing but the distance traveled divided by time, which is velocity. So how is this velocity connected to our electrons? Consider an atom. Inside there is a nucleus. Surrounding the nucleus there are many shells, and in the outermost shell there are many free electrons. These free electrons are always in motion. They are moving in a random direction. But we know that current is nothing but flow of charges, and in particular flow of electrons. So these electrons are also moving. We say in current also electrons are moving. So what is the difference? So according to this concept, it means that any object that is made up of atoms, which is almost everything in the world, should contribute to current. But that is not the case. For example, even if I take, say, a conductor, when it is simply lying down, it will not contribute current because of the moving free electrons. So what is the concept behind it? So let me consider conductor. It has many electrons in it, free electrons. So in this conductor, if one electron is moving downward, one electron, according to the basic physics, it should move in the upward direction. It's the law of physics. If one electron is moving right, then one electron must definitely move left. If one electron is traveling diagonally downward, then one electron must definitely travel diagonally upward. So this means that the number of electrons in any direction must be equal to the number of electrons in the opposite direction. So that means the total number of electrons that are moving are equal and they are traveling in the opposite direction, which means current flow is not possible. So when is current flow possible? When I connect this conductor to a battery or a power supply, then only current flow is possible. Then only what will happen? All these electrons will begin to flow in a direction opposite to that of the negative terminal of the battery, and simultaneously current will flow in the opposite direction. So this is how current flows, and the velocity or the speed at which these electrons travel is known as drift velocity. So in summarizing, we can say that drift velocity is nothing but the average velocity that an electron possesses, that is acquired by the electron within a conductor. When is this process happening? Where it is subjected to an electric field. So the four keywords are average velocity acquired by the electron inside the conductor where it is subject to an electric field. So these electrons will always move in a zigzag manner like this. And the velocity with which these electrons move is represented by Vd with an arrow mark. The reason we are taking an arrow mark is because it represents a vector quantity, which means it has both magnitude as well as direction. So now we are going to derive the drift velocity. Before that, we need to know two terms. One is tau, the other one is A. Tau is nothing but mean free time. Mean free time of what? The time between two successive collisions is called as the mean free time, tau. Similarly, A is nothing but acceleration of the electron in an electric field. Here again, A carries an arrow mark representing it to be a vector quantity. Okay, so first I am going to look at the basic concept. Force is equal to mass into acceleration. This is something we all know, basic law of force. Can I write F is equal to m into a? I am representing it in a simpler term. Okay, so F is equal to m into a. Now, can I write a is equal to F divided by m? I am just simply rearranging this equation such that a is equal to F divided by m. Now, we have already seen in our first unit a relationship between F and the electric field. What is it? I am representing both A and F with arrow marks, meaning that they have direction. So the relationship between F and E is nothing but this. E is equal to F divided by Q. So can I write F is equal to E divided by E into Q, where Q is nothing but the charge. Okay, so I can write F is equal to Q into E divided by M. So here Q is charge, and in particular what is that charge? Electron, negative charge. So I am going to represent the electron as minus E. Okay, so minus E I am going to place here. So A is equal to minus E into electric field divided by M. This is my acceleration. Now I have to connect my acceleration with velocity. Okay, I know that velocity is nothing but acceleration into time. Okay, so that means I can represent it as Vd is equal to A into, what is time here? Tau. Okay, and arrow mark here, arrow mark here. So Vd is equal to A into tau. Now I already know what A is. So I am going to substitute A here, so that Vd is equal to, what is A? Minus E electric field divided by M into tau. Okay. Now I am going to club some of the terms. Okay, I am going to club tau, E and M. Okay, so I am going to write Vd is equal to minus E tau divided by M into electric field. Okay, so I'm going to write it this way. Now this E tau divided by M is nothing but mu, which means mobility. So Vd is equal to minus mu into E. So this is my final equation, that is Vd is equal to minus mu into E, which is nothing but my drift velocity. Okay, so I have seen what is acceleration, I have seen what is drift velocity, I also know what is mu. Okay, so to summarize, okay, yeah, so we have seen what mu is. Now we are going to derive mu. So we know that Vd is equal to mu into E, okay, minus mu into E, but mu, this mobility factor, is a value. Okay, it is a scalar quantity. Okay, that means there will be no sign for it. It will not carry a positive or a negative sign. So what I am going to do is mu is equal to Vd divided by E. I am going to represent it as Vd divided by E, and I am going to represent it in magnitude. Okay, so this is nothing but mobility. I can define mobility as magnitude of drift velocity per unit electric field. Okay, okay. So to summarize, what and all have we seen? We've seen acceleration. Okay, we've seen acceleration. We've seen velocity, drift velocity, and we've also seen mobility. Now I'm going to see the SI unit of all these three quantities. So SI unit means, so time I will measure in terms of seconds. I will write 500 seconds, 600 seconds, isn't it? Similarly, each term, how can we write it as units? Okay, in terms of SI units. So velocity is nothing but distance by time. Okay, so distance means meters divided by time, second. Okay, acceleration is nothing but velocity by time. So what is velocity? Meter by second. That divided by second, nothing but meter by second square. Next, mobility. Mobility is nothing but velocity by electric field. What is velocity? Meter by second. And what is electric field? Electric field is nothing but volt divided by meter. So this is nothing but meter squared divided by volt into second. Okay, so this is my SI unit for acceleration, which is nothing but meter per second square. For drift velocity, meter per second, and mobility, meter squared by volt into second. Okay guys, thank you for seeing this video with me. If you like this video, please hit like and subscribe to my channel. Thank you.